moving ahead with the new topic which we have is the congruency of triangles. We have learned what congruencies usually the triangles hold. Okay, so considering those congruencies, we are going to start solving the questions. Let's see over here. It says that which postulate can be used to show that the triangle ABC, this is the triangle ABC, and this is the triangle FGH. So which of these two triangles are by what congruency they both are same is what we are supposed to say in here. So what do I see? The first thing that I see is this side is equal to this side, these two sides are equal to each other, and this side is equal to this one. Okay, so one thing that pretty sure that I can see is the triple S property is agreeing with it. Now some students would say, what about the 40-degree angle and the 80-degree angle? Now if I consider A is equal to F. Do I know the F angle? I don't know the F angle. So I cannot say by any angle means they are same. Okay, so but I can say just because they have given that the sides are equal already. Okay, they said that this side is equal to this one. Then they said that this side is equal to this one. And they said that this side is equal to this one. So by this method, I can surely say that by triple S postulate, they are same. Okay, which triangle is congruent to triangle FGH? Okay, so I have this triangle in here. So F as what did I say? I said that when you're checking for congruency, F should be congruent to the other one. So FG is what I have here. FG is this side, and so the TS is this side. So the first two alphabets will be TS, and after the TS, obviously the R would go in. So here it is triangle TSR. Sometimes if I say that TRS is same, which is completely wrong, because in that scenario FG would be similar to TR. It is not happening as such. So we have to see the mapping, how we are mapping it, and then we are supposed to give our answer correctly. Okay, now here what did I check again? If I want to explain it, I checked that F and G is a line because they are talking about the lines. Now that FG line is this is the other line. So what is the name of that line? It is TS is the name of that line. Then automatically the H goes here and the R goes here. So the triangles become FGH and triangle TSR. Okay, moving to the next question. It says in triangle ABC and PQR, it is known that AB is equal to PQ. Okay, I'll quickly draw the triangle ABC is what I have, and I have a triangle PQR, and they are saying that the side AB is equal to the side PQ. Fine. Angle A is similar to angle P. Fine. Complete the statement. Fine. What is the statement we are going to say? Let's see over here. If angle C is equal to angle R, this angle is equal to angle R, then you can use the angle side theorem or ASA postulate to prove that these are same. Okay, so complete the statement. The two triangles are congruent to each other by AAS or ASA congruency. That is what we are supposed to show here. Okay, nothing more. What is the congruency that they are following? We are saying that the two triangles are already congruent to each other by angle side. If I'm going this way, I read it as angle side. But if I'm going this way, I read it as angle side angle postulate. These are the two postulates we are using in here. Okay, next one. Which additional statements are required to prove the triangle ABC and LKM using the postulate is if L and A are same? So there's this triangle ABC, and you have another triangle LKM. Okay, and they said that angle L is equal to angle A by SAS congruency. So here there is angle in the center and sides at the corners. So this side and this side is what we will be talking about. So here I can say that angle side AC is equal to side LM. Okay, this side. What is happening here? This side is equal to this side. And this side will be equal to this side here. Okay, so I'll write that now. And that if I write it, it becomes AB side is equal to LK side. Why is that so? It is because if the angle is in the center, we have to take the two sides as the possible ones, isn't it? Because the angle is in the center. So angle is here the two sides will be this side and this side, this side and this side, and automatically this side will pertain to this side and this side will pertain to this side here. So the two things that we are going to pick out and say is that they are same. AB is equal to LK and AC side is equal to the LM. But why we are just showing two things? Because we are using the SAS postulate only. So that is what we have to explain it to it. Which triangle must be congruent to triangle ABC? This is the triangle that is given to you and you are supposed to check which one is same. So here, what is the postulate you will apply? The postulate that we will apply is side, angle, side. So we see that 50 degrees should be between 4 and 6 measurement sides. So 50 degrees is between 4 and 6. So it is side, angle, side also. Here this 50 degrees, if you see, A1 is correct. But here if you see the B figure, this is 6, this is 4 and the 50 degrees after it. So it is by side, side, angle congruency, so not possible. Moving to the next one, side, side, angle congruency, not possible. Side, side, side congruency, not possible. So it is only option A, which is the correct answer. Moving next, match each postulate or the theorem to the pair. Okay, so you're supposed to look at the figure and you're supposed to give name of the postulate that you seen is being applied here. So let's name the units that we have, measurements that we have. We have here the angle is there, the side is there, angle is there. Angle, side, angle. So it is by ASA congruency that we are doing this. Okay, next one we have is side, side, angle congruency. Side, side, angle. So both of them are following the same rule. So it becomes side, side, angle congruency is being followed here. Here it is side, sorry, it is angle, angle, side. So it is angle, 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 side congruency is what I have. Angle, angle, side congruency is what we have. So here, what is the exactly ones that we are following? Okay, so we have to name them. Okay, so SS, now here if you see SAS is given, that means double S and A is there. So it is the A congruency. From here, if I write this down, this represents the A answer. A is SAS. Then this is representing the B unit. So I would write the alphabet. We were not supposed to write this. We were supposed to write the alphabets choosing from down. And then the C goes to this one. So the C is for this one. Okay, moving ahead. It states that in triangle ABC, angles are given to you, sides are given to you. The other triangle is there, DEF, okay, and they have given you the units for each of them. And you have to justify your answer, is both the triangles congruent to each other? So quickly, whenever there is congruency, write down the triangles that you have. I see there's A, there is B, and there is C. I'm always going in the clockwise direction. Remember, whenever I am doing it in the clockwise direction, so that it becomes, to name, it becomes easier for me to solve it. Okay, then it says angle A is 35 degrees. So I'm going to write here 35 degrees is what I will write, and I have AB is equal to 4 and BC is equal to 2.5. Okay, cool. Then I will go to the other triangle DEF, which is given as angle D is 35 degrees. Okay, and then we have DE as 4 and EF as 2.5. So here I can say that by angle side congruency, okay, by angle side congruency, the triangles are similar. How is that so? So you will write the possible answers that you see. What is it? Angle A is equal to angle D is equal to 35 degrees. Okay, and then you have the side AB is equal to the side DE, which is equal to 4, and the side BC is equal to EF side, which is equal to 2.5. Therefore, by ASS congruency, the triangle ABC is congruent to triangle DEF is what I will write. Okay. Now, one thing that I was saying is I wrote it in the clockwise direction. What did I write in the clockwise direction? The A, B, and C that I have here. This I wrote it in the clockwise direction, D, E, and F. Okay. Why? Because if I change one of the patterns, I write this. Supposedly, I'm writing this in the anti-clockwise and this I'm writing in the clockwise. Then the alignment will completely change. The figures will become completely a mess to simplify on with. Okay. The next question that they have given us, a flagpole is supported by two cables of equal length. Okay, so here you have the flagpole and it is supported by two cables. This is one cable and this is the other cable that is there. So when I look at it, it looks like an congruent triangles to me. So this would be one of the congruent triangles, which is BAD, or if I am reading it as, if I have to read it in the clockwise direction, that becomes BDA. Okay, it becomes BDA, and this is the other triangle which goes as BCD. Okay, that is there. Now, if both A and C measure 55 degrees, angle A and angle C is measuring 55 degrees each. Okay, and AD, the side AD is equal to the side CD is what they are saying. Then the triangles are considered by ASA or SAS postulate. Since the BD side, yeah, what they're saying is the BDs. Now, I am saying that the triangles are congruent. The triangle BDA is congruent to triangle BCD. How is that possible? First and foremost, this angle and this angle, it is already given to me that they are same. Then this side is equal to this side. This is also given to me. Then after that, I will see that the side BD is equal to the side BD, because BD is a common side for this and it is a common side for this. So I will write here that they both are common sides. What I'm writing here, they both are common sides is what I am writing here. Common side, I can just write it. So this makes the triangles congruent. If the triangles are congruent, automatically this side will be equal to this side also, and this angle will be equal to this angle. This angle is already 90 degrees here, so also this angle will be 90 degrees too. So this is what we are saying. Now, what postulates are we taking in here? You can also use the ASA theorem. What is the postulate we are using? The angle, side, and side postulate. So the side angle, side means this postulate is what we are taking. Now, how are they taking the ASA postulate? Let's see that. Angle, there's an angle here, there is one more angle here, and there is the side here. So this 90 degrees, this angle and the side is showing them the ASA congruency. But what we decided to do is we took into consideration, what did we take into consideration? We took this angle, we have taken this particular angle and this angle. Then we took this side is what we have taken, and this side is we took. Another thing we took is this side is common to both of them is what we said. So we just stuck by the angle side, and it can be also written as side angle side also. Okay, so this is how you prove that they both are same here. Okay. Use the following diagram to answer. Okay, they're asking us to answer. So what are we going to answer here? Let's see to it. Okay, so they have given us this particular triangle. Look over here. What all are same? This side is common to this triangle and it is common to this triangle. So we will just write it. AC side is equal to AC side. Okay, now first, before that, I'll write. How am I supposed to write? I'll show you. This is triangle 1 and this is triangle 2. So we'll write in triangle ABC I'm going. ABC and triangle ADC. I went like this and I'm going like this here. Okay, what is exactly happening here? Okay, the side AC is equal to AC. Why? It is the common side. It is the common side for both the triangles. Then this angle has been marked for me already and this angle is same. So I will write angle A is equal to angle A here. Okay, and this angle are same. So angle C is equal to angle C. They both are already given to me from the figure. Okay, therefore by what congruency are you going to use here? The congruency that we will use is angle side angle congruency. Angle side angle congruency. Triangle ABC is congruent to triangle ADC is what we will write. Okay, now they wrote the angles in a different way. Now what did they write? Like, because angle A is not the complete angle here. Okay, it is not the complete angle here. It is divided. This part, if I read it, I'm going to read it like this: BAC, because this line is extending to C, this line is extending to B, so it would be read as this angle. I'm going to read it as BAC, and this angle, if I read it, I'm going to read it as DAC. That's what they have done. BAC is congruent to triangle DAC. Then this angle, how do I read it? It is read at BCA, and here it is read at DCA. Okay, so BCA and DCA are same. Then also one more thing, the AC side is equal to AC side. Okay, fine. Now for proving the congruency, three things should be same. What should be there? The three things should be same is what we see. So here they wrote it is given, and AC is equal to AC. You can write either it is the common side, or you can say it is the reflexive property of congruency. Okay, you can say it is the reflexive property of congruency, and hence the two triangles are same. And what is the reason? They are same by angle side angle congruency. Okay, they are going to use the angle side angle congruency is what is being used here. Which statement is justified by reason 3? Reason 3, that reflexive property is there. So what goes in here? It is obviously the side A is equal to side AC. Side AC is equal to side AC, because that is the reflexive or the common side between the two triangles. Which reason justifies statement 4? Statement 4 is ASA congruency. So we will write ASA postulate. This is the postulate that we are doing for this one.